I'm going to show out the square root one separately because it's messy and long, and we don't have time for messy and long in class. On a normal year, I'd spend 20 minutes doing it, but time is limited this year, and so I don't want to spend 20 minutes on one problem too much. So for now, we're going to move on to y equals x e to the x. And as we're doing this problem, start to kind of build in your head as we do this what this is going to mean for what the graph is going to look like. And point of inflection. Feel free to get a head start on me here. It's going to be a product rule. First, times derivative of the second, derivative of e to the x, still e to the x. Plus second times derivative of the first. Derivative of x is 1. And so if we're looking where this is 0, let's take an e to the x out. No calculator, by the way, here. If we need e to some power, we'll just leave it as e to that power. We won't put a decimal here. So if we take an e to the x out, first we need to figure out when is e to the x 0. When is e to the x 0? Jumping ahead here. That's where x plus 1 is 0. So negative 1 is one of our critical points. Is there an exponent I can put here and then have the answer be 0? Huh? Give me the answer again. 0? E to the 0. Oh, that's going to give us 1. So there's not. E to a negative is going to give us a fraction. There's nothing here that's going to give us, if you think about an exponential function, exponential growth typically looks like this. This is what e to the x looks like. So it's got that horizontal asymptote at 0. A horizontal asymptote at 0, that means it never gets to 0. So e to the x, this isn't going to happen. Domain, by the way, is from negative infinity to positive infinity. We can plug any number into x. We can plug any number into e to the x. No domain problems there. Negative 1. So we're going to pick a number to the left of negative 1. Well, we just saw that this is always positive. So all we really need to worry about is the x plus 1. Because it's going to be a positive times whatever this is. So if I pick a number to the left of negative 1, I get a bigger negative number plus 1. That's going to be negative times positive. If I put something to the right of -1 like 0, it's going to be positive. Changing from negative to positive, that means we're changing from decreasing to increasing. Which means we have a max or min. That's a minimum. Minimum if we're changing from going down to going up. -1. The y coordinate here would be negative -1 times e to the -1st. E to the -1st means we're going to take e and put it on the bottom. No maximum. So far our picture we're building is that we were decreasing and then we hit a minimum in some way and then start increasing at -1. That's the picture that should be in your head right now. That could be a lot of different functions, a lot of different curves, but hopefully our second derivative should help give us another picture. Oh, I didn't put a y prime. There we go. That's better. Okay. Y double prime. All right. Whichever form you want to use, either way you should get the same answer here. I'm going to use this form, x e to the x plus e to the x. We already know what this form is, what this derivative is. Derivative of x e to the x is x e to the is the first derivative we just took, x e to the x plus e to the x. But then I also have e to the x. Well, derivative of e to the x is e to the x. So this part is that product rule that we've already done, so I'm just going to write out what the answer is. And then this part is the derivative of this e to the x piece that's added on at the end. Good on that?
Wait,
Yes?
we can combine these, right? We can say 2e, can we say 2e to the x? Well,
So that's going to do next.
not changing. I can combine that with these steps.
You can't combine these,
Right.
but you can combine these. Actually, what I would do here, that's one way to do it, but what I would do here is take an e to the x out. Then we have an x, plus taking e to the x out, I have 1, plus taking e to the x out, I have another 1. We want to set this equal to 0. 1 plus 1 is 2. Very good. This is why we're in AP Calculus. And e to the x is not going to be 0, like we've already talked about. This part's going to be positive. So to the left of -2, this is going to be negative. To the right, it's going to be positive. And so that means we go from concave down to concave up. So while I get the rest of this here, I want you to, I don't even need like an XY grid. I just want you to try and come up with a rough sketch of this curve. And the features we're looking for, don't forget, what we're looking for is that we're decreasing, and we're concave down until we hit our point of inflection at -2. Then we start being concave up and hit a minimum at -1, and then we're increasing and concave up the rest of the way. That's what this should look like. So see if you can make kind of a rough sketch of what that looks like. -2e to the -2 is -2 over e squared. There we go, that's better. Actually, I'm going to take away the x and y axis as well, because I don't want you focusing on specific points. There we go. You see our rough sketches.
So like obviously there's a pattern in this, right? Like we got it goes from e to the x plus times x plus 1 and then x times x plus 2. Like would that pattern keep going if we kept going with this? Like we took like the third derivative would be x plus 3, like because we're just gonna keep taking the derivative of e to the x. You know what I'm saying? And then it's just gonna keep e to the plus 1. Like is that like what's
How do you know we're going to keep adding an e to the x?
I don't. I just haven't figured this out.
Well, if you were to be able to know
Right.
whether you would keep adding an e to the x, that would answer your question, wouldn't it?
Because the derivative of e to the x is like, so yeah.
So, like, this would stay the same.
Right.
And then what would happen here?
Just take another e to the x out. Oh yeah.
Here's where the e to the x keeps getting added.
Right.
That's where that pattern would stay the same.
It's always gonna be the top.
So in this function, you could say that the nth derivative is x e to the x plus n e to the x.
Oh.
So the 45th derivative of this function is x e to the x plus 45 e to the x. Here's what your curves should start to look like. And again, this is a rough sketch. This isn't, this doesn't have to be exact, but we should be starting by going down and then being concave down. So starting to kind of make a frowny face, but we're decreasing. And then until we hit -2, at -2 we hit an inflection point. We start going from concave down to concave up. And then at -1 we hit a minimum. And then start increasing. And it's going to be an exponential thing. So it's going to start increasing a lot more. But these are the important points. This is what should be going on at -2 and at -1. And you should start to kind of be able to construct and draw that curve. Here's the actual graph. So it's concave down ever so slightly. And then if I bring my my x-axis back, there's -2, so there's my inflection point. There's -1, there's my minimum.